Hello friends, we are going to solve the problem of Tower of Hanoi. Tower of Hanoi is a problem where we have got three towers and a number of disks, and the goal is going to be to move the disk from one tower to another. The tower A is going to be the source tower and tower C is going to be the destination. B is going to act as an auxiliary tower. Let's write the code for this and come back to the solution. We'll be taking the number of disks as 3 to start with. We'll have a function which is going to take the number of disks, the source tower, the destination tower, and an auxiliary tower. Every recursive function has a base condition. Our base condition is when the number of disks are 0, then return. Tower of Hanoi is a problem of tree recursion. We are going to write the code for now and come back to see how the recursion tree is created. We'll be calling the function twice, but we need to print the step that needs to be taken. The output that we are expecting is the steps that we have to take to achieve the goal. We'll be getting 7 steps here. We'll come back to the time complexity and how the number of steps are 7 for 3 disks. Here we print the step number. Here the step, the disk number, move disk from source tower to the destination tower. Call the method again. Okay, so in the problem statement you have seen that we have taken 3 disks. It's red, green and blue RGB. Let's create a map so that we don't need to bother about the disk number, and we have the disk color. Disk color map. And 3 is blue. So we have a map. The first disk is going to be red, second green and third blue, as we can see in the diagram. Instead of mapping to the number, let's map to color. Step, let's try to get the step number. So creating another variable here, let disk step count start with 1 and step count plus plus. Now we don't need step. Step count move disk from 2. Okay, this looks fine. Let's save and run. Okay, my bad. Let's call Tower of Hanoi with number of disk, source tower as A, the destination tower is C, and our auxiliary tower is B. Save. We have got some output here. Step 1 to 7, move disk read from A to C. Okay, so our program has executed and we have got the steps that have to be taken. Let's try to see if this works for us. Move disk read from A to C. A to C. Move disk green from A to B. Let's remove disk and put it here. Run it again. Yeah, this is more explanatory. Move red disk from A to C. A to C, done. Move green disk from A to B. Okay. Move red disk from C to B. Fourth step, move blue disk from A to C. Fifth, move red disk from B to A. Move green disk from B to C. Move red disk from A to C. So as you can see, we have achieved our target of moving the disk from tower A to tower C. Let's try to understand the tree recursion here. So the steps, we had 7 steps, and the tree is going to start with the first call, which was done on line number 16. Here we had the number of disk as 3. Reaching the line number 10, the number of disk is going to be 2 and then 1. Here the base condition will be met and the number of disk will become 0. So we will get the first step, which is moving a red disk from A to C. This is going to be in order traversal. After this, it will go to the parent, meet the base condition, and print the second step, which is about the green disk going from tower A to B. And this will continue till we get the desired output. Let's try to understand the time complexity. As we can see, the number of steps are 7. The time complexity for this is going to be 2 to the power of n minus 1. So for our case, the value of n was 3. So 2 to the power of 3 is 8 minus 1, 7. We had 7 steps. Let's try to change this to increase the number of disks to 4. As you can see, we have got 15 steps for 4 disks. We have undefined value at some places because the color of the last disk is not defined, but this should be fine. Once you have more disk, you can add it to the disk color map. I have added gray here. Okay, so this can be n number of disks and the complexity is exponential. As the number of disks will increase, we can again see for 2 to the power of 4 minus 1, we'll have 16 minus 1, 15 steps. As you can see, we have the 15 steps listed here, and this can be scaled for any number of steps.